Hello, Jerry Cunningham, Week 7 homework help exercise 7.6, the tennis match. All right, so I just made up a couple of fictitious names of tennis players, Michaeli and Ryan, and let's just read through the exercise. It says, a tennis match requires that a player win 3 of 5 sets to win the match. If a player wins the first 2 sets, what is the probability that that player wins the match, assuming that each player is likely to win each set? As likely to win each match. So they're equally likely. Okay, so what does equally likely? First of all, let's make sure we're all agreeing about what that is. When I think about that, it means something like, Michaeli has a 50% chance of winning any one of the sets, and so does Ryan. You've heard that before, 50-50. Okay, when we're talking about probability, it's 0.5, and Ryan is 0.5. They add up to 1. That gives you the universal set. It's going to happen one way or the other. Either Michaeli and Ryan are the only 2 singles player on the court. One of the 2 of them is going to win. Okay, that's how it works. So setting up this problem, a couple of things I'd want to think about, okay, and I'll put on here, which is that I want to understand, what it looks like. What are the possibilities? What are the different probabilities, the outcomes? So how many different ways can Michaeli win once she has won set 1 and she wins set 2? Now, what's the chances she's going to triumph over Ryan in this match? So there's kind of 3 scenarios, right? Because there's 3 more games. Michaeli could win set 3, okay? If she gets a win there, then she's won 3 out of 5. She's done. The alternative is that she could lose that. If she loses that, she could win in set 4. Or she could lose in set 4 and win in set 5. Oop. Maybe I should have brought it down a little bit more. But anyway, the thought is that there's 3 other possible ways that that Michaeli can win this match. So she could win the 3rd set, she could win the 4th set, or she could win the 5th set and win the match overall. So one of the really handy tools for looking at this problem is a probability tree, if you will. So we have the probability of A occurring, which I'm defining A as in set 3, Michaeli wins. So we're starting off right here. And even though there's been 2 wins, you might say that influences the outcome, but the only thing that really does, if you look at it mathematically, is it's telling us that you're starting off with 3 games and only one of them needs to be won by Michaeli to win the overall match. So we have 3 sets to go, and she can win any one of those 3 in order to win the overall match. So if they have an equal likelihood of winning, then each of these paths, so in set 3, there could be a win or a loss for Michaeli, and either way, there's a probability of 0.5. So the really nice thing about this is the probability that Michaeli wins set 3, so P of A actually equals 0.5. So I'll just put that up here, equals 0.5. Okay, now what if Michaeli loses the 3rd set? Inconceivable, I know, but let's say she does. Now they have to go on to a 4th set between Ryan and Michaeli, and what we have now is the probability B, okay, that Michaeli lost the 1st match and wins, or lost the 3rd set. She lost the 3rd set but wins the 4th set. Okay, so she has a 50-50 chance losing that, so she's now got down this path, there's a 0.5, but there's an equal likelihood again here. So of Ryan winning or Michaeli losing, there's a 0.5 chance, and this direction for Michaeli winning in the 4th set, there's a 0.5. Now what's so handy about putting this chart together, for what it's worth, is that what if the likelihood was not equal? Then you could put, she's a much better tennis player, so maybe she's got a 0.75. Ryan only has a 0.25 chance of winning, and then you would just put those numbers here instead of the 0.5. In this case, you got to come down this path and then this path to make this win possible. So the probability of B, which is that she wins the fourth set and wins the match, is 0.5 times 0.5. So probability of B equals 0.5 times 0.5. Let me make that into an asterisk. It'll look a little better than all the points, okay? Which equals 0.25. Okay? So that's the probability of B that McKaylee wins in the fourth set and wins the match. Now, again, inconceivable that McKaylee would lose both the third set and the fourth set, but let's just say, for sake of argument and for finishing this problem, that she did. And now there's another 50-50 chance down here when we are in, I wrote probability of C. That's also set number 5. Well, you heard me say it. You may not be able to read what I wrote. But anyway, so there's a 50-50 chance down here as well. So there's 50% chance that McKaylee will get a win. So now what we have is 0.5, 0.5, and 0.5. So probability of C, which is that McKaylee wins in the fifth set, therefore cinching the 3 wins necessary to win the match, and she wins the match. So that one is going to be equal to 0.5 times 0.5 times 0.5. Okay, which equals 0.125, I hope. Okay, and you can't quite see that if I move the paper underneath there. Okay, now why did we calculate all these 3 things? Because there's 3 possible scenarios. There's probability A, probability B, and probability C, each of which, if any one of those occur, then McKaylee wins the whole match. So let's just put in what we found as the probability for each of those. We found that probability of A occurring, which was that she won in the third set, was 0.5. The probability of her winning in the fourth set, which is probability of B, that's 0.25. And the probability of her winning in the, losing the next 2, set 3 and set 4, but winning set 5 is 0.125. And now what we need to do is, because any one of these, it's this or this or this, we need to add these together. So basically, the probability that McKaylee's going to win the whole match, the whole shooting match, once she has 2 wins behind her in the first 2 sets, we need to add up the 3 different possibilities. So in this one it was 0.5, this one it was 0.25, and this one was 0.125. So let's just see, 7.5, that looks like 875. So there's an 87, okay, remember you move the decimal point over 2 if you're translating between a decimal and a percent. So there's an 87.5% chance that McKaylee's going to win this overall tennis match. Okay, does that make sense? So in this one, you can see I probably should have made these more to size. There's only a 0.125 probability that it would not be inside the A, the B, or the C. So those circles would have had to have been much huger, if there's such a word, in order to accurately represent, because that would be a very small amount of this universal set left. I'm not even going to be able to draw it as big as it probably needs to be. But anyway, you get the idea, and hopefully that helps you with that problem.